Railway transport in Britain is at an all-time high. With such frequent use, safety on the nation's rail has become increasingly more important.
To understand the work that is being done at the university, I'm here to meet Christopher Johnson, a key member in the school's research.
I work here as a senior lecturer at Manchester Metropolitan University. My research expertise is in machine vision systems, particularly for the rail industry. I'm also the pathway leader for the rail MSc we're also designing, and we're working closely with industry to try and improve the skills gap which is currently suffering from. So the state of track inspection technologies in the UK for rail and light rail industry is advancing quickly, but it's still not up to the level which it could be. A majority of it still relies on individual walking and visually inspecting the line for surface-bound defects especially. Things like RCF or squat, corrugation. They're all potential defects that could be easily picked up with a machine vision system, so using a high-speed video camera to look and inspect the surface of the rail and eliminate the risk factor of having someone actually walk along and visually inspect these things. So my research here started way back about 7 or 8 years ago with a European-led initiative to improve the light rail industry. I started developing a machine vision system to visually inspect the rail, looking for these surface-bound defects, and this is advanced from these very simple kind of visual inspections to passive inspection using MEMS technology, which analyses the signature tune of the vehicle as it passes over the track and looks for patterns and reliability in the way in which it reacts. The projects currently ongoing at the university are focused around the Marvin suite of technology, and these are the vision inspection systems, the MEMS-based systems, but also laser profiling. So we're fully automating the suite, allowing a company to take a full kind of dynamic picture of the rail asset, looking at surface-bound defects, classifying them, looking at growth over time, taking the 3D profile and looking at wear rate over time, so you can actively predict when you need to replace track, and also looking at the signature tune from the MEMS technology, so that each vehicle can be inspected for its interaction, so that if there's certain defects with a wheel set or something on individual vehicles, that can be picked up and corrected before further damage occurs to the track.
In order to ensure safe travel, tracks must be monitored and maintained sufficiently to keep transport routes free from danger. A prime example of why this is needed is the prevention of rail disasters, such as the Hadfield rail crash in the year 2000, caused by rolling contact fatigue. This is a common rail defect which is easy to detect and repair.
The current technology has been adopted by Sheffield Supertram to trial it and make it more industrialised. So a lot of it has been up to TRL level 6, where it's been tried in the environment, but it's not necessarily suitable for an untrained technician to mount and use the technology. So we're working closely to try it all out, basically put it all in a box and make it nice and secure and make it as easy for the light rail sector as well as the rail sector to utilise this technology. For the future, there's lots of research grants available with the modern developments in Crossrail and HS2. There's always room for improvement, and as technology develops so quickly, there's a lot of use to apply it in different fashions. We've just put a bid in for some research into developing a modern bogie, looking to improve its capabilities in terms of monitoring. So again, it's one of these where visual inspection is used heavily to inspect its capability to look for defects and fractures or any failing mechanisms. So what we're going to do is invent a very novel suite of sensors. We've already started kind of working on a few of them, and incorporate this into our signature tune analysis technology, where we use machine learning algorithms, not necessarily to kind of develop when the component's going to fail, but have a look at what condition the component's in, look for changes as it goes on, and then characterise that as it's going to fail, or when it needs maintenance, or where preventative action can be put in place.
The ever-increasing strain in public transport and the ever-growing populace. Research here at Manchester Metropolitan University paves the way for much-needed innovation in rail safety.